Okay, welcome back everybody to Inside Astronomy. I wasn't happy where I left the last video because I owe you a proper explanation of flats. At the time, I couldn't quite visualize it as I would like to. Unfortunately, I didn't have the right visualization to be able to explain why flats are a division. I do now. A little bit of Python, a little bit of AstroPy and Matplot library, and I'm able to show you now what a flat looks like mathematically. First of all, flats are calibration frames. Yes, you heard that right. You need to treat your flats as calibration frames, and that's coming from someone who learned that lesson a little too late. I used to treat flats as something like, well, I'll get to them when I can. No big deal because I can use synthetic flats or some other technique to cover up for the fact that I didn't use flats. And to be honest with you, to a big extent, the dynamic background removal or automatic background removal will save you a little bit from flats. They will help to take some of the optical defects out of your system. So, you know, I'm giving myself a little bit of a get out of jail card, but I want you to understand flats are really important in this day and age, especially for astrophotographers. So there are some very nice cheap tools available, such as these artist pads. I have two of these. This is the A4 one, and I do also have an A3 light pad that I use to make flats. However, for some of my telescopes, even the A3 pad is not big enough. So what do I do then? No problem. Then I'll go to the drawer and I'll get myself a nice white t-shirt and make myself a t-shirt flat. It's quick, easy and simple. Again, making flats is not difficult, especially with Nina, where it will automatically set the exposure time for the flats for you as it's making them. The difficulty in creating diffuse light source is, as you just saw with a t-shirt, is very simple. No problems to make a nice diffuse light source. The main issue with making flats is the light source itself. Now, I tend to make them in the early morning after an imaging run, because let's face it, I don't know when an imaging run may occur. So after an imaging run, when it's overcast in the early morning, just before the sun fully rises, it's cloudy outside, and you get that lovely diffused light. If necessary, I'll double the t-shirt in thickness to reduce the light, to bring down the exposures so I can make them a little bit longer, more in line with my biases. The reason I like to bring the exposure length down to a few seconds is with these artist pads, you can, if you're running too fast, if the light is too intense, then you can see a flickering or a pattern through them, which is of course not what you want. You want a nice soft even light to make your flats. So bring it down to a few seconds is the best way to ensure that. With the small pad, you can just put a few pieces of A4 paper across it. With the bigger pad, a few A3 pieces of paper will help bring down the brightness of the light pad and also help with the diffusion to get it into the right zone. So you've all seen flats, you probably know what they look like, but I'm now going to show you what it looks like mathematically when you plot this thing out. Of course, you're expecting, depending on the telescope, you're expecting the center to be brighter and to see some vignetting into the corners where they're slightly dimmer. And of course, they never look great because this is greatly stretched. And add to that dust motes, and you've got what is your average flat. Well, here on the screen you can see the intensity plot there on the left hand side. This is effectively an intensity plot of the brightness. It's quite a flat image, and as you can see, there's only 0.05 of an ADU difference from the darkest area in the corner to the lightest spot in the center. But now you can see that the center is, let's say, 0.05 times brighter than the corner. Now notice what I did there. Yes, this is what I wanted to get to. Why flats are divisions, because effectively the intensity brightness mapping is showing you how many times brighter the center is than the corners. It's literally a record of your optical system. It could be because you're using the wrong T adapters on your telescope. Maybe you need T48s or 52s and you're only using 42s. It could be that your telescope is just not capable of fully illuminating the sensor you're using. Maybe you're using a full frame sensor. Or it could be some other reason. And this is one of the reasons why I never really gave flats much consideration, because as you know, I tend to buy telescopes with that can fully illuminate, or so they say, fully illuminate full frame sensors and even larger. So why do I need flats? But those donuts can be a challenge to remove from your images. So why not take the flat and make sure you can remove them automatically? And just a little tip for you here, the size of the donut, it will be, of course, smaller as it's on the sensor. As it's on the glass in front of the sensor, it becomes larger, and of course larger still when it's on the adapter, probably a reducer in your imaging train. Any donuts that are on the objective lenses will never be seen because they're just so diffused. So if you're looking to target or find out where or what needs cleaning, just look at the size of the donut, and that will give you an idea of its proximity to the sensor. Anything that's not within the zone of the sensor itself and your adapter, you can forget about. Well, that's it for flats. I hope this explanation suffices. I hope you now can see what I was trying to explain earlier in the last video, which was long enough already. I hope now you can see why flat fielding your images is important to you and why it is a division. So with that, I'll say goodbye for now and wish you all a Merry Christmas and a Happy New Year. So this will be my last video, at least in this year. Thank you very much for joining me. I hope you find the information here that I'm presenting useful, and can give me a like and subscribe. And I realize that people are joining from all over the world to view my videos, and it's really appreciated. We're just over 230 subscribers now, and to be honest with you, for a small astronomy channel, that's great. It is great. I've unlike most YouTubers, I have no subscriber goal. I would like to say thank you to each and every one of you for joining, and I wish you a very great, wherever you are in the world today, I wish you much love and happiness. So a very Merry and Christmas and a Happy New Year, wherever you are. Bye for now.